Hello, welcome to our class for today. I hope you are doing very good and also that you are enjoying our lectures on this platform and channel. Please, this is Noble Mind Science Tutors Online and we are bringing physics to your very home. So if you have not subscribed to this channel, please subscribe. Click on the notification button so that when we upload a new video, YouTube will notify you. Also give us a thumbs up if you like what we are doing, and also please encourage us by inviting your friends, telling them about this channel. Alright, so for today we are going to discuss displacement. For this particular class, we are going to talk about displacement. So that is what we are discussing for this class for today. Okay, so what is displacement? You know, we just talked about distance, position, distance. We talked about those ones. So now, displacement is the distance covered in a specified direction. We said that distance is the space between 2 points, but in this case, we are talking about displacement. Displacement is the distance covered in a specified direction. So as far as there's a direction in displacement, it means that displacement is a vector. So displacement is a vector quantity and it has the same unit with distance. It has the same unit with distance, which is the meters. So if you want to calculate or measure the distance, or I mean the displacement between 2 points, you will look at the initial position of that point, then the final position of the object. The initial position, that is from the starting point of the object to the final point of the object. Then you use this formula. Displacement is final position minus initial position. Final position minus initial position. So this displacement, because it is a vector, it can be represented by this vector notation. Like change in d. Displacement is change in d. This is differential of d, change in d, delta d is equals to d final minus d initial. And that's what I represented here. df is d final, that is final position, and di is initial position. Okay, so depending on the reference or the point of your reference, displacement can either be in the positive direction or negative direction. Depends on your point of reference. So like in this particular case, if 0 is my point of reference, so movement towards the right side or to the east side is positive movement. Then from this 0 to movement to the left side or the negative x-axis is negative displacement. Movement to this side, negative displacement. To this positive side is positive displacement. Now, displacement is also like the shortest distance between 2 points. Distance is the total length between the 2 points. The total length between the 2 points, that one is distance. So like in this particular example, say that a car starts from point plus 2 centimeters. So this is the drawing. This is 0.2 centimeter and stops at point minus 3 centimeter. So if this is the reference point, it means that the car started from this positive side and it moves to this negative side. So this is the initial starting point of the car, and then this is the final stop point of the car. Whereas determine the displacement of the car and the distance covered. So determine the displacement of the car and the distance covered. Now, the distance covered by this car is just a measurement of the length from this minus 3 to this point. But the displacement, using this formula, the final position of the car, d final of the car, is given to you to be minus 3, and d initial is plus 2. So if you use this formula, you see that the displacement of the car, that is changing d of the car, your d final, which is minus 3 minus plus 2, which is d initial. So this gives you minus 3 minus 2, which gives you minus 5. Gives you minus 5. So this tells you that the car is moving in the negative direction. This tells you that the car is moving in the negative direction. So this is the displacement of the car, but the distance is just this space. The distance is this space, the space between minus 3 and if you look at the space here, you see that each of these lines, they are separated by a 1 unit distance, 1 unit. So you count it 1, 2, 3, 4, 5. So that gives you 5. 5 gives you 5 centimeters. Okay, so the total distance covered, in this instance, there's no direction, so distance is equals to 5 centimeters. So you can see that between distance and displacement has a direction, saying that it's negative direction, but distance is just the space between them. So distance is 5 centimeters, while displacement is minus 5 centimeters. That's minus 5 centimeters. Okay, so this is displacement, and then this is the distance. We're going to look at some examples. Okay, so this is another example. A man walks a distance of 500 meters to the east. He then turns around and walks 300 meters due west. Find the total distance covered and the resultant displacement of the man. Alright, so this one, if you have your if you can draw, maybe can just represent it like this and say, okay, see, this is my 0 mark here. This is my 0 mark. So movement to this direction is east, and movement to this side is west. So if you have your gradation here, okay, so this is 0. So I have this 1, 2, 3, 4, 5. So each of these marks can be separated by 100 meters. So this will be 500 meters. Okay, so this is 500 meters. That's 500 meters. Then here, 1, 2, 3. This is 300 meters in the opposite direction. Okay, so what you are required to find now, you are looking for just this distance. That's what you are looking for. Okay, so for displacement, the total distance traveled for this this man is 500 plus this. That is total distance traveled. So that will be 500 plus 300. So that gives you 800 meters, right? Yes, this is the total distance traveled. Now for the displacement, using the formula that displacement is equals to d final minus D initial. Your D final is 300 meters. Your D final is 300 meters. And this is your D initial, 500 meters. So that will be 300 minus 500. So, and this gives you 200 meters. So you see that this is minus 200 meters. Minus 200 meters. So this is the displacement. And for you to have the minus sign, it means that it is moving opposite to its initial direction. It means that it is going opposite to its initial direction. So that is the meaning of this negative sign. It is going opposite to its initial direction. You know, the man started towards east, now it's going towards west. So this sign tells you that it's going opposite towards the initial direction. So for this particular displacement or this particular journey, the displacement is minus 200 meters. Minus 200. While the distance covered is 800 meters, just add the total distance, gives you the distance covered, 800 meters. So that is how to calculate distance and displacement. Displacement has a direction. Distance does not have direction. It only has magnitude, but displacement has it too. Okay, so that is for that. We have another example here too, still to drive home this point. This question says a boy walks 30 meters east to point A and then 40 meters north to point B. Find the total distance covered by the boy and then the displacement of the boy from its original point. Displacement of the boy from its original point. So this we can also represent with a simple diagram. So assuming the boy starts from point O and he moves east, say east 30 meters, then he now goes north. Okay, he moves from O to A, right? And he now goes north to B, say 40 meters. This is 40 meters, right? Then this is 30 meters. Okay, that's what the question says. So what you do in this case, just complete the triangle now. You just complete the triangle. Sorry, my drawing might not be too straight, but you can make your own very straight. So, okay, fine. So this is what you have, right? So if you draw this triangle very well, you are going to have a right angle triangle. This is a right angle triangle, and automatically it tells you that what you will use to find the distance OB, or the displacement of the man. The displacement is distance OB. Why the distance covered is the distance OA plus AB. So the total distance covered by this man is OA plus AB, which gives you 40 plus 30. Okay, 40 meters plus 30 meters gives you 70 meters. This is the total distance covered by the man. What of the displacement? The displacement is the shortest distance between O and B, and this is OB. This is the displacement of the boy. This is the displacement of the boy. So to find this distance, you use the Patagoras Theorem, right? Use the Patagoras Theorem. So if you apply the Patagoras Theorem, you have that you have OB squared is equals to OE squared. Sorry for that. It's equals to plus AB squared. AB squared. So you bring your values there. OE squared is equals to 30 squared. You have 30 squared plus 40 squared. If you do all that, you're going to have 900 plus 1600. So when you add this together, you have 2500. So what you are looking for you are now going to find the square root OB. If you square both sides, OB, that OB will be the square root of that 2500. So if you find that square root, what you are going to have will be 50 meters. 50 meters. So from this calculation, you will see that the displacement of the boy, the value of the displacement of the boy is less than the total distance covered. So this is 50 meters, and that is the distance OB. Distance OB is equals to 50 meters. So basically, that is how to solve for displacement and then to solve for distance. So calculations in displacement and distance, they are simple. Displacement has direction, distance does not have direction. Okay. Okay, so this is the distance, difference between distance and displacement. This is what we just discussed now in the last calculation. Look at the part of this journey. This is the total distance covered. This is the total distance covered. But the displacement is this shortest distance between the initial point and the final point. The shortest distance between the initial point and the final point gives you the displacement of this particle. Just like for this car starts from point A, from A to B, B to C, C to D, D to E, and E to F. So the distance covered is the sum of A, B, B, C, C, D, D, E, and E, F. But the displacement is the distance A, F. This is the shortest distance between A and F, because this is the starting point and this is the final point. So the shortest distance between A and F is the displacement of this brown car. So that is the difference between displacement and distance. And here it is. Distance is a scalar quantity. Displacement is a vector quantity. Distance has magnitude but no direction. Displacement has magnitude and direction. The two, they are measured in meters. The two are measured in meters. So basically, this is the difference between distance and displacement. Okay, so this is your test page. Please do this simple assignments. They are actually past JAM and WAEC questions. Do them and put your answers in the comment section. Or you can click on the WhatsApp link. If you click on the WhatsApp link, from there, it will take you to our WhatsApp chat page. Put your answers there. I will look at all of them. I will check all the answers. The ones that are not correct, I will comment. The ones that are correct, I will also comment. Okay? So thank you very much for your time. This is where we are going to stop this class for today. Thank you for your time. So please, if you have not subscribed to this channel, please subscribe to our channel. Give us a thumbs up if you like what we are doing. Encourage us so that we'll continue to bring out more videos. Besides that, when you subscribe, click on the notification button so that whenever we upload a video, YouTube will notify you. So thank you so much. Invite your friends. Tell them to come and join you to enjoy what you are enjoying in YouTube. So we'll see you in our next class.